we're going to start the first example. This example is going to explain how you can find the rate of return in general cases. So we're going to start with example 7.1. And in this case, this engineer, he's investing, or her, investing $250,000 in a new equipment. And she estimates the annual operating cost is going to be $10,000 per year, and income is going to be $80,000. And at the end of 5 years, she's going to sell the equipment. The salvage value is $100,000. We want to know what the rate of return is going to be. So the best way to do it is just draw the cash flow diagram for the problem. So this is going to be the cash flow diagram. The initial cost is at time 0, $250,000. The annual operating cost for 5 years, this is year 1, year 2, 3, 4, and 5. Is going to be equal to $10,000. The income from year 1 to 5 also is going to be uniform, and that's going to be $80,000. At the end of 5 years, the salvage value for the equipment is going to be $100,000. We want to know what is the rate of return from this investment. So obviously, we have several payments. Some of them are uniform, some of them are single payment. So what we're going to do is we're going to use the present worth method. We call it PW or R for revenue equals the PW for cost. So first, we're going to discuss the income. Actually, we have income of $80,000 that can be offset by the operating cost. It's going to be net income is going to be $70,000 uniformly from year 1 to 5. So we're going to have $70,000 times P given A, the present worth of uniform payment. I is unknown because on I star, which is your rate of return, and 5 period. Then we have the salvage value. So which is 100,000 times P given F, I star, and 5 period. So that's basically is the present worth of revenue. Now we're going to have the present worth of cost. Actually, you have only one cost, which is the initial cost at the time 0 is $250,000. And that's going to be equal to 0. If we can find an I which can satisfy this equation, that's going to be my rate of return. Unfortunately, this equation is very difficult to solve because if I use the P given A equation and P given F, it's going to be a huge equation in terms of I, and it's very difficult to solve here. So one way to do is just use trial and error. So what we're going to do is we try to give an I. If you're lucky, if this satisfies equals 0, then that's our rate of return. But normally, it's not going to happen. You have to do trials several times here. So I'm going to start with I 15%. I select arbitrarily 15%. So what I'm going to do here is I'm going to substitute in this equation, see what's going to happen. And 5 period. So basically, just substitute for I. P given F, 15% and 5 period, minus 250,000. If you go to the table, find the P given F, P given F, P given A from the table, and find the result here, you will see that the number you're going to get is going to be equal to positive $34,360. Now, if I substitute for I equal 20%, that's my next guess. Normally, try to find two consecutive interest rates, which one of them is going to get the positive value, the other one will get negative number. Then you can interpolate in between. So for 20%, so we're going to do the same thing. P given F, P given A, this time 20% and 5 period, plus 100,000 P given F 20% and 5 period minus 250,000. And that's going to be this time going to be a negative value. It's going to be negative $440. So obviously, my I is somewhere between 15 and 20%. Why? Because for 15% I get positive, for 20% I get negative. There's some value for I that's going to give me the equation and go to 0. Continuation of problem 7.1. So now what I'm going to do, we try to interpolate. So for I, 15%, the net difference between the present worth of revenue minus present worth of cost was $34,360. At 20% was negative $440. So we are trying to find an I call this an I star, which is your rate of return. Such a way that the difference between the present worth of revenue and cost is going to be equal to 0. That's going to be my rate of return. How are we going to do this? We're going to do a linear interpolation. I'm going to call the difference between these two numbers A, the difference between those two numbers B. And also we're going to call this one C, and the difference between those percentages is going to be D here. Even the relation is not linear, within some small range, you can assume linear. So that's why normally select your percentage very close as much as possible. 5% normally is acceptable. So the ratio A over B should be C over D. So the C is going to be equal to A over B times D here. So what is A? A is the difference between 34,360 minus 0 divided by B, which is the difference between 34,360 minus 40. The sign is important. You have to put the sign here, negative 40 here, times the D here. The D is the difference between 15 and 20%. Once you do this, you're going to solve for C here. Your C is going to be equal to 4.9%. Now, since this I is increasing, my rate of return, which I call this an I star, is going to be equal to 15 plus 4.9%. So that's going to be 19.9%. So this is the rate of return for this investment. Now, this is our rate of return for this investment. So what I'm going to do next, I'm going to draw the relation between the I, the interest rate, and the difference between the present worth of revenue minus present worth of cost. At I equals 0%, it's very simple. If you substitute the equation in the rate of return equation, you're going to get 200,000 positive. And then we did for at least 2I. I'm going to show you this one here. So for example, at I 20%, I get negative value of 440. So this is 0%. So you get negative 440. At I 15%, so this is 15%. We got the number 34,360. So one value gives me the difference negative, the other one positive. This intersection is nothing more than your rate of return, which is I star, which is 19.49%. So basically, at this point, the difference between the present worth revenue and cost is going to be 0. So that's why this is my rate of return here.